Let us look at this another useful concept called line of intersection of two planes. So here I have two planes. How do I find the line of intersection of these two planes? So if I have the equations given in this form, r bar dot n1 bar is equals to d1, which is your first plane, and then r bar dot n2 bar is equals to d2, which is your second plane. Right? This is a dot product, right? So you have n1 and n2, you have d1 and d2, everything available with you. How do you get this line of intersection? So these planes, they intersect along some line, right? Two lines intersect on a point. Two planes intersect along a line. Can I find this line? So to find this line, to find any line for instance, we just need two things. We need the dr's of the line and we need a point on the line. So this is the first thing, dr's of the line, and we need a point on the line. Let's see how we can do that. So that's not difficult. So to understand this, the most important thing that we need to understand is if your n1 cap, n2 cap, which is coming out like this, n1, n2 bar, and n1 bar is pointing like this, can you actually visualize and tell me the direction of n1 cross n2? n1 cross n2? So I'll simplify it for you. If I place n2 here, so for instance, if my n1 is something like this, and n2 is something like this, then n1 cross n2 will be a vector. You have to put a screw here, rotate from n1 to n2 through a smaller angle, right? Through a smaller angle, and it's basically perpendicular to the plane containing n1 and n2. So it's something like this, That is what you will do here, and what you will understand is n1 cross n2 vector will look something like this, right? Which will be parallel to this vector. So this vector and this vector will be parallel to each other. So what I'm trying to say is this line of intersection will lie along n1 cross n2. Remember this is an extremely important point, If you know the dr's of the normal, or if you know the vectors which are normal to two planes, their cross product will lie along the line of intersection of the two planes. So now I need the dr's. I got the dr's of the line. So if I know n1 cross n2, this n1 cross n2 we know will give me a vector. It will give me a vector of something like ai plus bj plus ck, right? It might give me a vector of this form. So abc will be the dr's of this line, right? But I also need a point on this line. So to find a point, what I will do is, if I have the plane available in the coordinate form, so for example a1x plus b1y plus c1z plus d1 equal to 0, and a2x plus b2y plus c2z plus d2 equal to 0, if I have them in their coordinates form, right? If I have them available in their Cartesian form, what I can do is I can put z equal to 0. So both of them will just reduce to a1x plus b1y plus d1 equal to 0 and a2x plus b2y plus d2 equal to 0. Now these are two straight lines, right? There are two straight lines in x and y. So you can always solve this. There are two equations in two variables. So you can always solve this, get xy, right? That means you got x, you got y, and you put z equal to 0. So xy0 is a point on this line. xy0 is a point on this line. So this xy, how will you get this xy? You will get them by solving these two equations. So now you also have a point on the line. You already got the dr's by using this cross product, and now you also have a point. Once you have these two quantities, you can use the symmetric form to write the equation of a straight line, right? This one, x minus x1 by a is equals to y minus y1 by b is equals to z minus z1 by c is equal to lambda, where x1, y1, z1 are basically this x1, y1, and z1 is 0, so you'll put a 0, right? And ABC, what are ABC? ABC you'll get after you do n1 cross n2, you'll get the dr's, right? So this way you'll be able to write the equation of the line. So as you can see, there is no direct formula, there is a procedure that you have to keep in your mind. So until you don't understand, just keep playing this video again and again, and I'm sure it will get in your head. This was all about the line of intersection between two points, between two planes. Let's move on to the next subtopic.